Alright guys, today we are looking at the Science Week 1 of Activate. And so if we look through here, this is a passage. We're looking at seismic waves and a picture of the Earth's core. And so if we look through, we can see that we've got S waves and P waves. And so one of the things we're supposed to do when we look at something like this type of question is we want to just look at the picture and kind of figure out what's going on. So we've got P waves and S waves. At seismographs, they're measuring those. We've got a solid inner core. We've got things moving around. Here's the focus of the earthquake. A shadow zone, that might be important. We've got only P waves received at seismographs. The figure is not to scale. Another shadow zone. So that looks like this is the shadow zone here and the shadow zone here. We're getting P waves, and over here we're getting P waves and S waves. And just P over here and nothing at these two spots. So P and S, and this is just P. Alright, so that looks like kind of what we're looking at there. Let's read the question. The question says, Figure 1 shows that a seismograph located at a point 125 degrees around Earth from an earthquake's focus would receive which types of seismic waves, if either, from that earthquake. So 125 degrees is going to be between 103 and 142 from point 0. So that means that 125 is the shadow zone, which means neither P waves nor S waves. So we've got neither. D is our answer. Alright, question number 2 says, according to figure 1, when P waves encounter the boundary between the mantle and the core, the P waves most likely do what? So when they hit this boundary, remember P waves are the dark ones, and so when they hit the boundary between that, there it looks like they do some bending or something like that, and they go all the way through. And so these P waves, let's see, they most likely stop and do not continue into the core. Well, that's P waves in the core, so we know that one's not right. Enter the core and are refracted. They do enter the core. I wonder if refraction, that's probably our answer, but let's just double check. They change to S waves. We know they don't change to S waves. They change to a third type of seismic wave. We only have 2 types, so it's not that one. It's not stop and continue. It must be G is our answer there. Our next question, based on figure 3. Alright, we got a new figure this time. In this figure, we've got the time to reach seismograph from earthquake focus. So this is time on this axis. Time, and this axis is distance. So we've got T and D, and you can see that it's taking more time for S waves and less time for P waves to go the same distance. So for a given seismograph, the time elapsed between the arrival of the first P waves and the arrival of the first S waves from an earthquake focus more than 10,500 kilometers away must be what? So the time elapsed between the two, this is in minutes here. So minutes, we've got from, here's 10,000. We're looking at 2,500. So well, let's just try this. This is 12, 14, 16, 18, 20, 22. That's from 2, 4, 6, 8, 10 seconds. This one's going to be more than 10 seconds, or 10 minutes. So if they're spreading out like that, we're probably looking at more than 10 minutes, which is our answer. Okay, so let's look at our next question. This one, we've got another question. It's right here. We're looking at a different figure now, figure 2, which has our time in the earthquake focuses, and then we're looking at the P waves arriving at a seismograph, and then S waves. And so we're looking at which one of these is a little bit bigger. We've got minutes, and so it looks like the S wave is a lot bigger than the P wave, or maybe that's what it says, okay? We've got our time, once again, our time versus our distance. And so let's look at our question. Our question says, based on the information provided, the time earthquake starts at the focus in figure 2 corresponds with which of the following points on figure 3, with figure 3 right here. So this time it starts at the focus versus the point is probably going to be this point right here where it starts. And so we've got our point 0, 0 right here, which is our answer F. All right, last question. According to figure 5, we have, according to figure 2, which of the following statements best describes the relative amplitudes of the first P waves to arrive at the seismograph and the first S waves to arrive at the seismograph. So the amplitude of the first P waves to arrive at the seismograph is what? So P waves, we said P waves is smaller than those S waves. All right, so the first P waves and the first S waves arrive a little bit and so the S waves are bigger, so the amplitude of the first P waves are smaller than the amplitude. Maybe it's A. Larger than the amplitude, they're not larger. Non-zero and the same as the amplitude, they're not the same. And 0, as is the amplitude. No, amplitude is how big something is. Amplitude is how high apart those are. So A has to be our answer. And that is passage 1, week 1 of Science ACT Prep. Thank you, guys. Double check our answers. D, G, D, F, and A.